Good afternoon, everybody. It's a great pleasure to be here. Yes, what I wanted to do with you today is share with you some of the work we're doing both at MIT, at the SENSEable Cities Lab, and also at our design office, Carlo Ratti. And this is about Internet of Things entering our cities and how that does a couple of things. First of all, it produces an incredible amount of data. That's what we heard already. And second is actually how this allows us a new interaction with the space around ourselves. Being Italian, I wanted to start with this picture. That's a picture that people used to be really fascinated. It's a Formula One racing picture, but it shows something quite interesting that's happening in Formula One over the past 10, 15 years. And 10, 15 years ago, in order to win a race, you needed a good physical infrastructure. Today also, you need a very good digital infrastructure, something like this that collects data from thousands and thousands of sensors onto the car, sends it to those computers where it's analyzed, it's processed, and decisions are made in real time. In other terms, for all of us who have a background in engineering, it's what we would call like a real-time control system. A system made of two components: sensing, collecting information from, in this case, the Formula One racing car, and actuating, responding to that information. And the amazing thing, we believe, is that today our cities are starting to behave a little bit like that Formula One racing car. Our cities are being covered, layered, with many, many devices. We just heard it in the previous presentation, with networks, with sensors, with all these kind of digital layers. And because of that, the way we can understand the cities and collect information from them and respond to that information is actually changing very rapidly. And that really is what people usually refer to as smart cities. In other terms, you could describe it as the convergence of digital and physical, bits and atoms coming together with us, architecture, design, and so on, and all those interfaces in the middle. Let me just give you one example. Again, I wanted to follow up to the previous presentation by Qualcomm. This is actually the growth of mobile connections on the planet. Now, it might be surprising today to think that just 30 years ago, we could live without mobile connections. The first commercial cell phone network is 1979 by NTT in Japan. And then it took over 20 years to reach 1 billion connections, and then growing like that, 2, 3, 4, 5, 6 billion connections. Now, there are 7 billion on the planet. How much more can we grow? And as we heard before again, predictions are to get to 50 billion estimated connections in 2020, mobile connections on the planet. Well, what does it mean? It doesn't mean that we'll move with 15 iPhones in our pockets. It simply means that we started connecting people with people. We moved connecting people with data, more and more people to machine to data, and finally M2M, a lot of machine connected to machine. Almost every atom out there of the physical world, we're becoming both a sensor and an actuator. Now, the first thing, as I mentioned, I want to talk to you about the data that this produces, and then at the end, we'll look a bit more about interactive architecture. So, about the data component, well, all of this, yes, means that we know a lot about what happens in cities. We collect a lot of data there. This is a famous estimate by Harry Smith. It's already a few years old, but if you take all the data produced by humanity from the beginning till 2003, that data is what we now produce every 24 to 48 hours. There's another definition of big data that I like, is by my colleague and friend Mike Batty at UCL in London, is big data is all what you cannot put in an Excel spreadsheet. This could be funny, but it's actually quite profound. It's the fact that when you got big data, such an incredible amount of data, then you also need new tools in order to process it. So you cannot cope with the existing software and tools that we use today. So as I said, I want to start with data components and look at 3 types of data we can collect in cities. First type is opportunistic data. It's the data that we collect, maybe for running a cell phone network, but we can use it in order to better understand the city. And that becomes very exciting. This is actually part of what we are doing here in Dubai with the collaboration of Do, the cell phone operator here. So about how all this data can be used to understand the city. Actually, at our lab, we were one of the first places worldwide to look at this data. What I'll show you in the next video is one of the first projects we did at the beginning, 9 years ago, in 2006. At the time, it hadn't been done. We collected anonymized and aggregated data from millions and millions of people, collected from the cell phone network, and tried to use it to understand how a city works. What I'll show you is actually in 2006, there was a big event. There was the Soccer World Cup. You might recall Italy and France were playing. Ultimately, Italy won the Soccer World Cup. And what you see here is actually what happened in the capital of Italy, in the city of Rome, during the final of the Soccer World Cup. You see here is before the match. People moving in the city here and there. You see the Colosseum and the river, making calls. It's the afternoon, and silence. Nobody talks anymore. France scores, Italy scores. Halftime, people make a quick call and go to the bathroom. Second half, end of normal time, first overtime. The famous headbutt by Zidane in a moment, and after that, Italy wins. You see, that night, everybody went to celebrate up there. That's actually the center of the city. The following morning again, the winning team went to meet the prime minister. And you see everybody moving there. And by the end of the day, there was a big party at a place called Circo Massimo. It's down here. And you see the peak at the end of the day of everybody moving there for a big urban celebration. So this shows, this is just the basic data. It shows you what you can collect. But then you can actually analyze this data in order to better understand cities. So what we did here in this project in the UK, we built the largest ever social network using non-internet data. And we used it in order to better understand cities, regions, and communities. So how people connect with each other. And what you find is a way to read the city and metropolitan areas that you couldn't have unless you knew about all these flows of how we're all connected with each other. Here's the idea. So how can we redraw the map of Great Britain? Using this network of interactions. Every time we got a phone call, we kind of create a link between two places. For the entire country, we get something we could call the human network. And then the question is, how can we use it? How can we use the human network in order to better understand communities over space? Neighborhoods, cities, metropolitan areas, regions. And if you look at this over the UK, about regions, for instance, you see Scotland, which is more or less like the Scotland we know. Wales, which is very different, is much more connected to the center of the country. And how, you build like a new geography, which is not based on history, not based on politics. It's really based on how we all communicate with each other and how the human network brings us together over physical space. Again, other things you can do with this data, you can understand the city as a dynamic system. This is Lisbon, using data from the taxi network. Again, taxis have GPS. And you can use GPS in an opportunistic way to better understand the city and flows inside it. Then if you analyze it, you can actually do something quite fun. What you see here is, again, taxi information. Yellow is a taxi pickup, and blue is a taxi drop-off. And here you see New York. It's a zoom on JFK Airport. For those of you who've landed there, you see all the terminals. Then you zoom out, you see all Manhattan and all of the boroughs nearby. And then you can ask yourself, what if people were ready to share mobility? Now, we know that these days sharing is very popular. We like to share our bedrooms on Airbnb. We like to share, many things in our life. And couch surfing, think about, many of the infrastructure is more and more shareable. Think about car sharing as well, which is transforming many cities around the world, like Milan in Europe has been totally transformed in terms of mobility by car sharing systems such as Car2Go. So the idea here was, what if not only you could share the car, but you could share the ride? You could think about a future when, cars or minibuses could move through the city and people could share them. Now, we used all the data from New York. And again, we had to analyze it in a new way. When you got this incredible amount of data, you need to develop, as I was saying before, new tools in order to make sense of it. That's a paper that came out a few months ago in PNAS, the Proceeding of the National Academies of Science in the US. And we developed this thing called shareability network in order to solve that problem. And what you find is quite extraordinary. that if people were ready to share mobility more, you could take everybody to destination exactly when they need to be there, but with just a fraction of the cars we use today, with 40% less infrastructure of what we have. So the idea that all of this can help us to run the urban infrastructure in a more efficient way. Now, if you combine that with self-driving, as you all know, self-driving is a reality. We're working with the government of Singapore, who just launched an RFP to make Singapore one of the first places in the world where you got shared self-driving mobility. The amazing thing about self-driving is not that you don't need to keep your hands on the steering wheel. That's not the point. The point with self-driving is actually that the car in the morning can give you a lift when you go to your office, and then can give a lift to somebody else in your family or to anybody else in the city. So what you're doing, you're blurring the distinction between private transportation and public transportation. If you combine what I was telling you before about ride-sharing New York, plus what will happen with self-driving, the combination of the two means a city such as Dubai, New York, London, or Singapore, or any city, big or small, where you can actually satisfy the full mobility demand with just 20% of the cars we have today. And think about potentially, this is just an estimate, potentially, if this happens, if people are ready to jump on those changes, and potentially, so then think about how different Dubai would be if you just had 1 car out of 5, taking away 4 cars out of 5, and still being able to give the mobility, satisfy the mobility demand of the whole city. Just a couple of other things that will happen, when everything will be self-driving. That will take a bit longer. Self-driving itself, the technology is there, technology is ripe. There are self-driving cars all around the world being tested. Audi is supposed to be next year the first manufacturer to launch self-driving level 3 autonomy level 3 cars off the shelf that you can buy. But a few years down the line, when everything will be self-driving, then something else might change in the city. Something like this. Now, you're all familiar with this. It's a well-known traffic light. And traffic lights actually were invented when cars arrived on our roads. But actually, when cars become more intelligent, you can think about a different system. A system that could look more like this. Don't try it yet. But basically, the idea that cars don't need to stop anymore, and then flows just magically mix. Again, that's an interesting mathematical question, and we were looking into that. What you see here is actually an intersection in Singapore. What you see is exactly the same number of cars to the left and to the right. To the left, we manage them using the most sophisticated traffic light in existence today. And to the right, actually, we're using a slot-based system as the one I was showing you before. And when you compare the two, look at the bottom, you see just after a few minutes the difference in terms of average delay per car and number of cars waiting to the left and to the right to manage exactly the same flow and with exactly the same safety condition, boundary conditions. All right, so this was just a quick glimpse into opportunistic data we can collect. We are collecting from the cities anyway for running, say, a cell phone network, a taxi fleet, you name it, and how we can use it then in order to do something different in an opportunistic way. Now, the other type of data you're familiar with is data we all generate. Again, because of IoT, we're all online, and we generate an incredible amount of data. In this project was a few years ago, we looked at Flickr. It was one of the first times that this was done using pictures. And then we asked ourselves, if you've got pictures, how can they tell us something about how people move over space? We did a project with the mayor, former president of the province of Florence, who's now the Italian prime minister, Matteo Renzi. And so what we did, basically, we looked at this as a way to understand better flows. Flows in Tuscany. You see to the left all of the region. And then in the middle, you see people zooming in and how people move and take pictures in the center of Florence. Then you still zoom in, and you can look at some of the main landmarks and touristic monuments in Florence, such as the Duomo. Now, if you do something slightly more sophisticated, you can look at the time exactly when a picture was taken. And then, at that time, you can create trajectories. And look at how different it is here. What this shows, it shows you how Italians and Americans move in Tuscany. You look at where they take pictures and the time of the pictures were taken. Now, I have got a question for you. So where are the Americans? To the left or to the right? So Americans to the left, raise your hands. You need to make up your mind. So either one or the other. Americans to the left, raise your hands. OK? And Americans to the right. OK, Americans to the left is the majority. And actually, you're right. Americans are to the left. If you come from the United States, you might go to Tuscany once in a lifetime or once every 10 years. And then you go to the main places. You see they go to the main cities, Genoa, Pisa, Florence, Siena, Perugia, the main attraction points. But actually, if you're Italian, you've been to Tuscany many times, you might want to discover new little villages like that in the middle of the region, and you move in a totally different way. Look at the little island called Island of Elba. There is virtually no Americans on Flickr there, but a lot of Italians who visit it. Again, you can do many other things. This is an analysis of Barcelona and the key places to go to Barcelona. You can look at semantic analysis, origin analysis to see where people are coming from. You can also look at the pictures. And in this case, in Spain, we look at the color of the picture. As you know, drought is a big issue in Spain. Like here in Dubai, it doesn't rain that much, and the country is getting drier and drier during the summer month. And the way that is usually monitored is by having sensors distributed to the country. But what if you could use all this data that we all generate? We call the project Los Ojos del Mundo, the world's eyes. If you could appropriate the eyes of all the people as sensors in order to understand drought and how it spreads to the country. And that's what you see by looking at the picture, analyzing the picture, and see how they change during the course of the year. Well, just finally, another type of data that tells us a lot about our cities is data that we all post. We post on Twitter, on Facebook, on Flickr, you name it. And on Twitter, for instance, you can get interesting things. In the next video, you will see how we use millions and millions of data points from Twitter and discover something quite exciting, that if you look at the tweets and simply the length of the tweets, you can understand very well the excitement on the system. And we looked at the golf tournament in the United States, and look at what happened. So when we tweet, we leave public digital traces that can help us to understand our reaction, in this case, to big events. Think about Dubai Expo or big events where people are really passionate about. So we looked at all of the golf tournament tweets in the United States. You see long tweets at the top, short tweets at the bottom. The yellow line is the average, the average length. And what you see every day before the match, people tweet, and you got the long tweets. And then during the match, actually, the length changes. If you look at it mathematically, you see some beautiful log normal distribution, very, very precise. And you see that this pattern repeats every day. Can we have the music? So anyway, you can look at this online. But again, how all this information tells us a lot about our cities and about our communal behavior as people, in this case, watching, for instance, a big event. The final type of data I want to share with you is data that we actually sense, because today it's very cheap to deploy sensors, and you deploy them everywhere. The first project is a project where we looked at this computer. Now, today you know everything about this computer. It's there on the table. Every chip in that machine, you saw where it was, you know where it was produced, how it moved on the planet, how it became this. But then a few years from now, you stop using it. At one point, somebody throws it away, and sometimes this is what happens to it. Sometimes, a lot of electronics, e-waste from the United States is shipped illegally to Asia, from Europe to Africa. So our idea, what if you could develop a little tag to put on trash and start following trash to see where it goes? It's a little bit like when you go to hospital, they put a tracer in your blood, and they follow it through your body. How can we do the same thing at the scale of an entire city? Well, we couldn't find the tag off the shelf, so actually we worked with Qualcomm. We know them very well. Actually, the founder was an MIT professor, and his son still is one of the key people in the company. So we work with them. You just heard their presentation before, in order to develop a chip that could be put on trash and then help us to follow it. And you see here some of the initial example. You know, it's almost like a miniature cell phone that will last for several months, with a battery that will last for several months, and we just get location and send it back and report it back. This was the first deployment we did in the city of Seattle. Can we have the sound? 500 volunteers and 3,000 pieces of trash. And after tagging all of them, we started following them. So you see here 3,000 objects. The day of deployment in Seattle. After a few days, you see some of the main landfills next to Seattle. But an actually big surprise, how far things started to travel. Sometimes in crazy, unpredictable ways. Look at the trace that went all the way to Chicago and then down to Baja California. And still moving after 1 month and 2 months. We thought the Firewall Symphony was the right music here. So, you know, what can you do with that? You can do a couple of things. The first thing, you're an engineer, you're an architect, you get all the traces, and you try to optimize them. Over the past few decades, we've been optimizing the supply chain. You know, the supply chain has been radically transformed because of the availability of real-time information in recent years. But nothing like this has been done for the removal chain. So we could do something similar. Think about how much energy we could save if we were to look at those traces and better understand how things could be moved and managed. The second thing that's very important is how all this information you share with people can actually promote interesting change of behavior. We said before we got an incredible amount of big data. Well, this data at the individual level means that we know more about the consequences of what we do. It means that, you know, we do something and we know what it does to the environment. In this case, when we throw away something, where it goes and what the impact is. And that per se, that knowledge can be a powerful force for change. And I'll give you just one example out of many. We were sharing all this information with the people during the deployment. And at the end of the project, somebody came to us and said, you know, I used to drink water in plastic bottles, like the ones here on the table, in plastic bottles every day, and they throw them away and forget about them. But now after the project, I know that those bottles, you know, go to a landfill a few miles from home. They will stay there forever, and because of this, so I stopped drinking water in plastic bottles, which is something that actually in the United States is becoming more and more common, that people have their own bottle and move around, but are stopping drinking water in plastic bottles. So the idea, as I said, you know, that data can actually be a powerful force for change in telling people about the consequence of their actions, so that you know, all of us, we can make different decisions. The third thing we discovered was a surprise. And that happened more recently. It happened when a burglar came to our lab at MIT. And the poor guy stole a lot of things, including some tags and computers that tell you where they go. So this is about, all what I showed you so far is about data, big data, more research project we're doing with our lab at MIT. I want to finish by showing you actually a lot of the work we're doing in architecture and design. That's done by our design office. And we're using a lot of the data we can collect from buildings, a lot of the kind of interactive possibilities opened up by Internet of Things, in order to see how we can design new things, new buildings, skyscrapers, or other things. In this case, one of the things we just opened a few weeks ago is one of the main pavilions at the World Expo in Milan. It's actually called the Future Food District. It's the district of the future that was, you know, that is at the expo. Every expo has had a district or a part looking at future trends and evolution of technology. And in this case, the brief we were given by the organizer was, you know, what can we do from the point of view of looking at consumption in actually a real supermarket. This place is a real supermarket where you can go and shop. So that's part of what we've done. And our idea was, you know, can we do something actually that looks a little bit like a market? Can we use technologies to go back to the idea, the old marketplace, but not in a way like you see here, in a way where technology is used in a very intrusive way. This is a supermarket by Tesco in Korea. It was actually closed. It was working for a while, but then it was shut down, where actually people need to have their phone in order to interact with products. We didn't like the idea to use technology in an intrusive way. We liked the idea to use technology in a seamless way. And we wanted products to tell us their stories. Again, information is vital. In this case, about the things we buy and consume. So how can you just put your hand next to the products and magically get that information that tells you about what you're getting? All that information is available today online. Think about a bottle of wine. You know everything about it. But that information doesn't reach you when you are in the supermarket. So in this case, we developed a system with Kinect. For those of you, who are familiar with the Xbox, Kinect is a system that recognizes the movement of bodies and hands. And then, so we use that in order to have projections in a magical way. You see some mirrors that reflect the products and show and give you digital information on the top of that. So as you are approaching a product, you will know much more of what you normally know about it. Now, this is the whole district is around 70,000, 80,000 square feet. What you see here is the supermarket. You see the different levels. The warehouse at the bottom, we wanted to show also where products are coming from and how they go up into the supermarket, how people can touch them and get all this information in a very seamless way. Sometimes also with the help of collaborative robots. Again, the latest development in robots, in robotics, is about collaborative things. It's not anymore about humans versus robots, which are in a cage, and like it was until a few years ago. It's much more about collaboration, and some of the boring stuff we can easily leave to robots, in this case, all the restocking in the supermarket. And then getting all of this kind of data visualization about all the things we know about the supermarket, like an aggregator of products coming from all over the world, going to the World Expo in Milan, and then from there spreading again across the world. Again, on the outside, we were given the box, so we didn't do the architecture of the box. We were given this as a built pavilion. We could do the outside, the skin, and the inside. But we didn't want to do like a new skin around it. We didn't want to do a fake facade just for the sake of beautifying the project. So we decided, well, let's leave it as is, as almost like an industrial place. But again, let's play with data. So on the outside, we built the world's biggest plotter that becomes like a way to show data on the outside of the pavilion as well. You can see, in this case, about an example with faces. The faces are the faces of people buying inside, and also plotted in different places based on what they buy. You see the average face of the vegetarian, or the person who buys organic, or who buys a lot of sugar and fat. And you see actually how those are taken inside and then used as input for the outside facade. Well, very briefly, this was the building of the supermarket until a few weeks ago. As you know, the Expo in Milan opened just the 1st of May. That's the first test with the plotter, the world's biggest plotter, that actually can spray paint. And here you see actually the build. The final results is getting great reviews and great success of public and in media and critics. And you see here all the aisles. The idea that it's more like an old market. People can talk to each other. Everything is on table. It's not on big shelves that create a discontinuity. So a new relationship between people and products and people and digital information to help us enhance all of that. In the final project, I could show you plenty of projects about what we do at the office. As I said, from new type of skyscrapers from the big scale of the city to the small scale of furniture. But I want to focus on two projects we did for Expo. In this case, it was the previous Expo. It was at Expo Zaragoza. The theme of the Expo there was water. And the mayor came to us and said, water has been a beautiful ingredient of architecture and planning for thousands of years. Think about all of the south of Europe. Think about this part of the world, how water has been used to enhance our experience of building in public spaces. So his question was, how can we use all this kind of ubiquitous computing? How can we use IoT, again, IoT, in order to create a new experience with water? And our idea was, imagine you have a pipe that you see there, and that pipe has a number of valves opening and closing very quickly, controlled by a computer. Then what you can do, you can create like a living water wall. A water wall where you can show images or text or patterns, and that opens up when you approach it. The mayor liked the idea, so we got the commission to design the building at the entrance of the World Expo. It's called Digital Water Pavilion. It's one actually of the few pavilions that were kept after the World Expo. You can still see it in Zaragoza. All the walls are made of water. No doors or windows, but when you approach it, it opens up to let you in. Digital images on the water, so digital pixel and physical pixel. Here it was myself trying not to get wet and testing all the sensors that open up the water wall when you approach it. And I should tell you now what happened one night. That night, all of the sensors stopped working. We build things that are more and more complex. We use IoT everywhere. Our cities are becoming like computers for living in. But then sometimes, as you know, computers crash. In this case, one night, all of the sensors stopped working. And that night, we were terrified because the building would still work, would still use the water and produce text or images or patterns, but stop responding to people. So we were terrified, but actually that night turned out to be one of the most fun nights ever. That night, thousands of kids from all over the city went to the building to play a new game. Not anymore a building that opens up when you approach it, but a building that you need to engage like this. And for us, that was important because as architects and engineers, we always think that we know how people will use the things we design. But then reality, especially human reality, and especially human reality when we build a much more interactive environment around ourselves, when we build smart cities, intelligent buildings, things that respond to us, well, all of that then is often a surprise. In this case, it was a good surprise. Thank you.
Very good presentation. It was amazing insight. The question which it's pondering on my mind is, how do you measure smart cities against each other? I know there's no standards, but how do you measure them?
Yeah, it's a great question, and we're seeing more and more indices of people saying, hey, this city is the smartest, and there's kind of a race. I think it's very difficult for different reasons. The key reason is that actually a smart city, if you define it, first of all, we need to define what is smart city. And if we define it as this kind of convergence of digital and physical we were saying about before, then it can have an impact on so many different dimensions. And we saw something here. You can look at mobility. You can look at waste. I didn't show it today, but you can look at water. You can look at energy. You can look at many other different dimensions. And so, you cannot really compare and put all of them in the same basket. So I think, on the one hand, first of all, if you say smart city, perhaps we should first start defining what we are talking about. Now, if you were to say smart mobility, there you probably can say something about how smart the city is from the point of view of how much it's using, taking advantage of digital technologies in order to improve mobility. And again, think about car sharing, ride sharing, think about, Singapore, for instance, is one of the cities who's pushing and betting most on intelligent mobility. It was one of the leaders and one of the, the first cities to adopt electronic road pricing to, have people pay if they use congested streets. So basically, that becomes a way, if you focus on one dimension, to compare them. Otherwise, I think it's going to be very, very difficult just to talk about smart cities in general. At the same time, I think it's very important to have gatherings such as this one, or some of the other ones we've witnessed in recent months, because there's a lot to learn between different experiments. We see people experimenting across different dimensions. So it's very important to bring those experiences together so they can be shared and we can all learn from each other. Yes?
Thank you. I don't have a question. I just have an answer to the questions that he asked. Okay. I'm Dr. Saeed Al-Dahiri. I'm advisor to the government. Well, ITU is going to come up with a smart city index that measures smart city progress around the world. And they're piloting with Dubai to start developing this index. There is an MOU which was signed couple of weeks back between the ITU and the Smart Dubai to develop an index for smart city that will be able to assess smart city ranking globally around the world. They came up with a definition. It's called the Smart Sustainable City definition, which is, I think, for the first time to have an agreement of what defines a smart city. So to answer your questions, the ITU is working on this with Dubai.
Well, thanks for mentioning that. I think it's very interesting. Again, I think we still need to be very careful about how we combine smartness in one dimension, say mobility, across maybe smarter in urban participation, and how we want to weight it. If you compare, for instance, Singapore, that's been investing a lot of smart mobility, with Boston, where the mayor has been pushing a lot smart technologies for urban participation, how do a trade-off? I think that's part of a broad question. But thanks for your contribution. Yes.
Thanks, Carl. That was great. I want to actually know from your work or experience, how are we using this interesting evolution in the digital world to actually become active in decreasing the huge gap that's just increasingly becoming bigger between the privileged and unprivileged, the poor and the rich. If we sit here and we talk about smart cities, and you can see this all around the privileged people, and I don't know if I know in MIT there has been really a clear sense towards the graduates going to volunteer, doing more of a community-based work. Are we doing anything to experiment with that at MIT?
Yeah. Thanks for the question. It's really a very good question, very important question. There's many answers here. What I will tell you is what I find encouraging. And what I find encouraging is a lot of this is actually allowing, in many cases, leapfrogging. You can think about mobile connections in Africa or in Sri Lanka. We did a project in Sri Lanka where we've been working across different dimensions, but there you can see fishermen who actually were able to leapfrog traditional markets in order to, just by using real-time information that was brought to them, real-time information about the price, in the case of fish, that was brought to them by mobile connections. So I think the interesting thing that we're seeing more and more is that a lot of these technologies are very accessible. And then in those cases, they can often promote leapfrogging. Basically, people jumping altogether a stage of technological development and being able to bring those who were behind ahead of those who were ahead before. And I think mobile payments in Africa also are another good example where Africa in some places is much ahead than Europe or the United States. So I think there's a lot of hope here, but that's something very important we always need to look at. And personally, I didn't show projects today, but we're working both in South Africa, in Brazil, in many other emerging countries in order to see how some of this can really help, and especially if you think about Brazil and favelas, how this can help underprivileged people.
Are these technologies, once developed by MIT, do they become available for the rest of us? Can we approach you to start using them, applying them in our societies?
Great. I will respond to the two questions. The first one about privacy, very happy to discuss with you. It's a very big issue. We've had a number of gatherings at MIT called Engaging Data, where we brought together privacy advocates, big companies such as Google, AT&T, the Obama administration, and many others to talk about this, about data, how we should use data. I'd love to discuss it in more detail. We think it's a very important problem we should all take very seriously. I think, if I start discussing in detail, probably we will have to skip lunch. But I want to say, have a look at Engaging Data and what we are doing there, because we think that's a very massive change we are witnessing, and we need to be very cautious about it and really have an open discussion about how data is used, who has access to it, how we should manage it. About the second question, yes, at MIT, MIT is like all universities, non-profit. We love to work with cities and with companies around the world. We just need to cover our research costs. And so a lot of what we do is available to first of all, to the partners we work with, and then is published so that the whole world has access to it. So very happy to start research collaborations with you. What we do in our design office works like, we do a lot of architecture, urban planning, and so on, using IoT you know, buildings like the World Expo I showed you and many others. And in that case, we work more like a design consultancy and design office. But yes, you know, delighted to explore this. Thank you very much for having me.
Carlo Ratti, it's been an absolute pleasure. Thank you very much indeed for your insights today. Really appreciate it.